Your WhatsApp group will have two mentors for you. So one of them is Nitish, and I'll be adding another mentor called Madhuri. So both the mentors will be guiding you. Of course, I'll also be there, but the three of us will be guiding you in whatever doubts any of you would have. I have turned on the recordings for this class, so whatever I speak now will be recorded. I think we can get started now. So first of all, we will learn the data structures that are there in Python. So that is how we start learning any language. We first learn the alphabets used in the language. Similarly, for a software language also, the first goal will be to learn the different data structures present in Python. Once we are comfortable with data structures, we will move to data manipulation, where we will try to manipulate data, because the data that we get in real life is often very dirty. So we have to do a lot of manipulation in data to get it to a clean format on which algorithms can be applied. So first data structures, then data manipulation or data cleaning, you can say, and then finally we go to the modeling stage. So the data cleaning part often takes as much as around 80% of a data scientist's time. So we have to understand different ways of cleaning the data. So we will talk about that in details as the class proceeds. So what I'll do is I'll open a Jupyter notebook. So how do you open Jupyter notebook? So once you have installed Anaconda, which the link for which I shared in the last class, so you will have, if you go to your start menu, just write Jupyter, you will see this Jupyter Notebook desktop app. So once you click that, you will have this open. So once this is open, you can browse to the particular location. Let's say you want to save your file at some particular location. You just click on these buttons and browse to that particular location. And then you click on New Python 3. So once you click on New Python 3, a new notebook will open for you, which will be like a new tab. So this is a new notebook which opened for me. So this is where I will do all my coding. So this is the console where I write everything. And right now it doesn't have a name, it has a name Untitled. You can just click here and give a name to it. So let's say I call it sample, and if I click on rename, and then if I go to the directory where I have this file, so if I go to this particular location, I will see that sample file created. So if I go to Day1, you see this sample file. This is what I just created, 8:37 a.m. So all Jupyter notebooks will have this extension IPYNB, which Jupyter notebooks are also known as IPython notebooks. You also have the feature to download them as these other formats. You can download it as HTML. So if you want to send it to somebody who doesn't have Python installed, you can always download it as HTML or as PDF also. Okay, these are the buttons that we'll be using. So whenever you write something here and if you want to execute that piece of code, all you have to do is just click this run button. There are a lot of shortcuts also. You can set your own shortcuts. So if I click on keyboard shortcuts, you will see there are plenty of shortcuts that are used. So for example, if you want to run a particular line of command, you can also write shift enter instead of clicking this button. So if I write, for example, 1 plus 1, I can write shift enter and it will give me the output. Or I can also click on this run button. So you will get comfortable with these as you proceed. So this is where we are today. We will be learning about the different data structures used in Python. So are you guys comfortable? Shall we start? Is the video proper? Are you able to hear me clearly? Okay, cool. Okay, so let's start with the first data type, which is called a list. Okay, the first data structure that we'll be learning about is called lists in Python. So what is a list? So the first few hours will be very simple, guys. So it might be a little boring also. You might feel that you are in a software engineering class, how you used to learn in school or in college when you learned C or C++ for the first time. So it would look like such a class, but this is important because we are starting from scratch. So I have to walk you through the basics also. Okay, but after maybe a couple of classes, the topics would get very interesting as I start talking about statistics and how statistics is used in data science. Then the classes will get very interesting. I would also bring a lot of real life examples where statistics, how it helps in taking a better decision. So then the classes would get very interesting. The first few hours may not be very interesting. Okay, so what's a list in Python? A list is just a collection of elements. Okay, so you have different elements, you just combine them together and it becomes a list. So for example, how do you define a list? We define a list using these square brackets. So I can write these square brackets, and whatever elements I give inside the square bracket, it forms a list. So I can write, for example, 1 2, I can write R, I can write Python. So this is a list which has four elements: 1, 2, R, and Python. These are the four elements in the list. Since you have combined them together, it forms a single data structure which is called a list. Now, just like in most languages, list they support indexing. So what do I mean by indexing? Indexing means you can access individual elements in the list by their position. Okay, so the position of the first element is 0. The indexing starts from 0. So this is 0, this is 1, this is 2, and this is 3. So the moment you write x of 1, and you will get 2 as the answer. So 2 will be the answer because 2 is the element which is present at index 1. So this is how you index or you access individual elements from a list. So this property of accessing individual elements from a list is known as, so the elements of a list are ordered. Okay, so elements are ordered. What do I mean when I say elements are ordered? The elements are ordered means they are arranged in a particular order. So one comes first and then we have two and so on. So this is called that they are ordered. Okay, so we will be referring to this property of data types whenever we can access individual elements using the index. So ordered means they support indexing. The moment I say that a data type has the moment I say a data type is ordered, it means that you can access individual elements in the data type using its index. Okay, so later we will see some other data types where they do not support indexing. So if they do not support indexing, you cannot access individual elements by using their index. So that means they are not ordered. Okay, so moving to Python now. So this is what I have written as the definition here. So this is a Jupyter notebook. It looks very cool. So you give comments by using hash, and these are these headings that you see here. How do I give a heading? You just write, you just give hash and whatever you want to write, and then you click on this drop down and select heading. So once you do this, you will get this as a heading, and you just press OK, and you run this line, and this becomes a heading. So it will be, the font size will be bigger than others. It will not be executed. So this is the definition of list: a collection of numerics or string or lists itself. So a list can have a list within itself also. So what I have given here is individual elements, but instead of individual elements, I can have another list. So that means you can have nested lists also. So this is a list I have defined. You can also change any element of a list from its index. So for example, I have defined a list here: x is equal to 1, 2, 3 Python. Now this element at the second index, the element at second index is 3 right now. So if I want to change it, I can just write x of 2 is equal to, let's say, some other name. So what would happen? 3 would get changed to Nitish. So next time I print it again, I'll see Nitish instead of 3. So this is how you can change any particular value of a list. And we have seen this, that you can access list using the indexes. So if I write x of 0, that means it will give me the first element, which is 1. Now what is this x of minus 1? So let's discuss that. Now just like you can access elements of a list from the left hand side, you can also access individual elements of a list from the right hand side. Okay, so from this side also you can access. How do you access this? So the indexes from the right hand side starts from minus 1. So this is minus 1, this is minus 2, this is minus 3, and this is minus 4. So remember, from the left hand side it starts from 0, but from right hand side it starts from minus 1. Okay, because minus 0 doesn't make sense. So obviously it has to start from minus 1. So you can also write, for example, x of minus 2. So x of minus 2 will give you r. Okay, because this is the element at minus 2 index. Now what if you want to access multiple elements simultaneously? So let's say if you want to access 0, 2, and it is all three of them simultaneously. So you can use the colon operator then. So what have I written here? I have written x 0 colon 3. What does this mean? This means that it will give me every element starting from 0 till the second index. Okay, it gives one less than what you have written here. So for example, if you write x of, let's say, 0 colon 3, it will give you x of 0, it will give you x of 1, and it will give you x of 2. So remember, it will not give you x of 3. This will not be included. It only gives starting from 0 till 1 less than this number. 1 less than this number that you write. So 1 less than 3 is 2. So it will only give me till 2. This will not be given out. Okay, so if I write this on this particular x, I would get 1, 2, and r. I will not get Python. Are you following, guys? Is everybody following? Vikram, you may need negative index because sometimes your list might be very big. Let's say if your list is very big, you cannot go on counting from the beginning, right? Let's say if your list has 20 elements and you want to access the element which is at the last position. So in that case, you will have to again go on counting. So sometimes it is easy when you directly pull it from the right hand side. That is why we use negative indexes. Bharti, is it not audible? Guys, I think I am audible to everybody, right? Bharti, others are able to hear me, so I guess it's a problem at your end. Okay. So any other questions do you have, guys? So when you write 0 colon 3, it will give you the 0th index, the first index, and the second index. It won't give you the element at index 3. Okay, so remember this. Now we have the append function for a list. Append function is used when you want to. So as the name suggests, append means adding. So when you want to add new elements to a list, you use the append function. So x, let's say x is a list, and this is your list x, which has 1, 2, Nitish, and Python. If you want to add another element to this list, we can use the append function. So I write x dot append, and whatever element I want to add, if I write here, that will get added at the end. Okay, so this is how the append function is used. So for example, if I write x dot append this entire thing will be added to the list. But remember, this will be added as another list. Since you have, so look at this carefully. Since you have this as a list, I have this getting added as a list. So we are getting a nested list basically. Okay, so this is a nested list that we are getting. Okay, and if you want to add an element at a particular index, let's say I don't want to add elements at the end, I want to add elements somewhere in the middle, then you can use the insert function. We use the insert function for this. So you can write, insert function will take two inputs. The first input is the index at which one you want to insert. So let's say I want to insert right at the beginning. So right at the beginning, the index is 0. So I have written 0. And then you write what is the element you want to insert. So I want to insert, let's say, A. So now when I run this, A gets inserted right at the beginning. So at the first position. Okay, so this is where A gets inserted because I have written 0 here. So 0 is the position at which you want to insert, and next the element that you want to insert. Okay, is that clear, guys? How do we insert nested list? So you can insert nested list similarly by passing this as a list. So if you pass this as a list, it will get inserted. This entire list will get inserted. Okay, right now I have just inserted a single element. If you want, you can insert an entire list. So let's say this is a list. If you write this within insert function, this entire list will get inserted. Okay. Now let's say I have a question for you guys now. You can write the answer in the chat box. Sriniti, do you have a question? You have raised your hand. Okay. So let's say this is a list that I have. Okay, no problem. Let's say this is a list that I have. I want you guys to print me. So I want you guys to print me this one and this as the output. So how will you get me B and Python as the output? So this is two questions. Question number one, you have to get me the element B as the output, and question number two, you have to get me Python as the output. So see guys, if you can do this, you can write the answer in the chat. I'll wait for your answers. Okay, Naresh says it's x4. What about the others? Always remember, guys, we only use square brackets to access using this. Okay, so we don't use, so I have used a square bracket here. Remember, I have not used this bracket. This will be wrong. Okay, you cannot use this bracket. You will have to use a square bracket. Okay, so let's see the answers. A lot of you have answered. So let's see how should we approach this problem. Okay, so I'll break this problem into small pieces. So first of all, first let's see the indexes in this list. So let's forget about what do we want as output. Let us understand which element is present at which index. So this x, it starts with 0, of course. So this is the 0th element. This is the first element. This is the second element. Now, which is the third element? Which is the third element for this list x? Now, at the third index, or at the index 3, we have this entire list present, right? So this entire thing represents the third index. Starting from here till the end, this is index 3. Okay, remember, this is something unusual. So this, since at the third index you don't have a single element, this entire list, or rather this entire nested list, is the third index. Okay, and then this is fourth. Okay, so if you write x of 3, what will you get? If you write x of 3, you will get this entire nested list. Okay, because this entire thing is present at this index, at the index 3. Okay, are you following, guys? Okay, now let's say you have written x of 3. You wrote x of 3 and you got this entire nested list as the output. Now this this also is a list, so this also will have the same way of indexing it. So now let us index this. So the index of this is 0, the index of this is 1. Now at the third index you again have a list, so this entire thing will have index 3, this will have index 4, this will have index 5. Okay, so if I write x of 3 and again 3, why did I again write 3 in square brackets? Because this is how you access elements from a list, right? So this entire thing is a list, and on top of that you are writing, oh sorry, this will be 2. Yeah, this is true. Okay, so then you will write 2 here. So x of 3 is this full list. Then after that, if you write 2, you will get just this 3 elements. So when you write x3 and then 2, you will get R2 and Python. Okay, now within this again you will have indexes. Within this again, this is at 0th index, this is at first index, and this is at second index. Okay, so now you get the answer. If I want B as the answer, what should I write? I will write x of 3. X of 3 will give me everything. I don't want everything, I just want B. B is at first index, so I will write 1 here. This will give me B as the answer. And then next, if I want Python, I will again write x of 3. This will give me the whole thing, but I don't want the whole thing, I just want this particular, so I will write 2 here. Now 2 will give me R2 and Python, all 3 elements. I don't want all 3 elements, I just want Python. So I will write 2 once again. This will give me Python as the output. So this is how you deal with or you access elements in a nested list. So this is a nested list. Okay, a list within a list. Is this clear, guys? Any questions on this? Okay, cool. Now can you answer the same question? The same question which I asked, can you answer this? But can you use negative indexes now? So this time we went from the left hand side. Now can you start from the right hand side and give me the same answer? So I want B and I want Python. But you can use only negative indexes this time. Yes, Hima, that's what I'm asking. So now you have to answer the same question, but you have to use only negative indexes. So try answering the same question, but only use negative indexes. Don't use positive index, only use negative index. Okay. Anil, you have a question? You have raised your hand. And you can mix them up also. Yes, Hima, you are right. You can mix them up. You can mix positive and negative index also. But sometimes it gets confusing, so we usually don't do. Because if you mix negative and positive, it sometimes gets confusing. So now what I want you guys to do is use only negative indexes and get me first B as the output and then Python as the output. So the same question as before. Okay. I'll wait for your answers. Anil, the class started at 8:30 at the scheduled time. So you will have the recordings available. Don't worry, Anil. Okay, let's see the answer. So most of you have answered correctly. Let us see the answer. So let's start from the right hand side now. Okay. So this time I will start from right hand side. So let me first erase whatever I have written. So I'll just erase these numbers. Okay. So what is the index of D? The index of D is -1 because it starts from -1 if you go on the right hand side. So index of D is -1. Then what is -2, which is the element present at -2? Now this entire nested list is the -2 element, right? Because this is at the position -2. So this entire thing is at -2. Then this is at -3, this is -4, this is -5. Okay. Now I want B and Python, both of these is inside -2. So first definitely I have to write x of -2. So your answer will start from here, x of minus 2. X of minus 2, if you give, you get this entire list as the answer. Okay, but you don't want this entire list. You want only individual elements from that list. So once again, we will have to start with negative index. So you can write this is minus 1, this is minus 1, this is minus 2, this entire thing is minus 3, this is minus 4, this is minus 5. So if you have to access, let's say B, then you can just write minus 4 here and B. Okay, but if you want Python as the answer, you will write x minus 2. Now Python is inside the minus 3 index, so you will write minus 3 here. But minus 3 will give you all these 3 elements. You don't want all the 3 elements, you want only one of them. So once again, this is minus 1, this is minus 2, this is minus 3, and you want Python, so you will write here minus 1. So this will give you Python as the answer. Is it clear, guys? Vikram, there is no end. It depends on your system's memory. Your list can be as long as you can have elements, basically. So it depends on the memory of your system. Okay. Sanil, I answered that before. You can mix them up also. You can use positive and negative together also, but it gets confusing. So I personally avoid it. But if you are comfortable, you can use. You can mix them up. You can use mix positive and negative also. That also works. Okay. So this is all that you need to know about list, guys. Yes, of course, Hers, I will be sending a lot of examples as homework. So in class, we will be discussing only this much. Of course, because we are limited by time, I cannot discuss a lot of examples in class, but I'll be sharing a lot of questions in the assignment. So you can practice that on your own. Okay. But this is pretty much what you need to know about a list. Okay. So quick revision, what did we see in a list? So we saw that lists are ordered. What do I mean when I say lists are ordered? Ordered means you can access individual elements by its index. So that is why I say lists are ordered. Okay. Then there is another property called lists are mutable. What does this mean? When I say lists are mutable, that means the values of the elements can be changed. Can be changed. So for example, if you have a list 1, 2, and let's say 5, and if you write x of 2 is equal to 4, and then if you print your list, if you print x, you will get 1, 2, and 4, right? So this means you are able to change the values of elements. This is called mutability. Okay, that means lists are mutable because you can change the values of the elements. Later we will see some data structures in Python where you will not be able to change the value. Okay, that means they are immutable. Are you following? So there are two properties. One is ordered, one is whether they are mutable or not. Mutable means if you are able to change the values of the elements, it is mutable. If you are not able to change the values of the elements, they are immutable. Okay, now I'll move to the next data structure, which is dictionary. okay, which is dictionary in Python. Now, what are dictionaries? Dictionaries are another data structures in Python which will always have a key value pair. Okay, so we define a dictionary like this. So you define it using curly braces. Okay, you will have curly braces to define a dictionary, and they will always have a key value pair, which means it will have a key and it will have a value. So let's say the first key is key 1, okay, and then it will have a value also. Let's say it is value 1. So the keys and values are separated using a colon. Okay, you use a colon to separate them. This is how you write. This is the first key value pair, and then you use a comma to separate two key value pairs. So this is, let's say, key 2 and this is value 2, okay, and so on. This is key n, this is value n, let's say. Okay, so this is a dictionary which has n key value pairs. Okay, you will always have to give a key and a value. Okay, you cannot skip that. So for example, I can write x is equal to, let's say I can write 1 and 5. This is my first key value pair. I can write, let's say, a and b. Okay, this is my second key value pair. They can be any data type. Okay, they can be numbers, they can be characters, anything. Okay, then I can write 5 and let's say d, and I can close it. So I can have a mixture also. See, I have a number as the key and I have a string or a character as a value. Here I have both key and value as character. Here I have both key and value as number. So any type is possible. Okay, so this is a dictionary. Okay, so X is a dictionary which has three key value pairs. This is the first key value pair, the second and the third. Okay, so this is what I have defined here. So I have defined a dictionary called Y which has four key value pairs. So these are the values. You have empty number 1, employee number 1 as Raj, employee number 2 as Vijay, and 3 and 4. And each key value pair is separated by a comma, and the keys are separated from their values using a colon. So this is how you define a dictionary in Python. Okay, now when I print y, you see something strange happens. What I am getting is the order is changed now. Okay, the order is the same, but so if I print this, this is what I get. Okay, but what you have to note here is that, so let's say if I write y of, let's say, 0. Okay, so I'm trying to index the first key value pair by writing y of 0. So let's see what I get when I run this. So when I run this, I get an error. You see, I get an error. Or you try any index. Let's say I try 1, for example. If I run this, I still get an error. So what does this mean? This means that dictionaries do not support indexing. Okay, dictionaries, they do not support indexing. So let me write this down. So previously we saw if a data type supports indexing, it means that that data type is ordered because each element is placed at a certain position. Now since dictionaries do not support indexing, I can say that they are unordered. Okay, so they are unordered means they do not support indexing. Are you following, guys? So this is often asked in interviews. Okay, so what is the difference between these two data type? So the difference is that lists are ordered, which means they support indexes, and dictionaries, they are unordered, they do not support indexing. Okay, so if you write x of 0, it wouldn't make any sense in case of a dictionary, it will give an error. No, we will come to that, Naresh. Hold on, we will come to that. Okay. Okay, so this will give you an error. Let me write it down here. Okay, they are unordered. Okay, so this is what I have written here. When you create a dictionary, Python doesn't care about in what order you wrote the elements, and it won't remember the order after the object is created. So you cannot expect a dictionary to print it in the same order. Okay, so right now it is just due to luck that it printed in the same order. Okay, it is just pure luck. It did not have printed it in the same order. So the order is not important here. Okay, that is what I'm trying to say. So Python dictionary is unordered. That means it cannot be accessed via indexes, and it is always defined by using curly braces, and they have a key value pair. So whatever we have discussed. So let me run this one. Yes, the key should be unique. I'll talk about this now. She knows. Okay. Now you see this dictionary. You see the second dictionary which I have defined here. It has this list as the value, so that is allowed. Okay, you can have any number of values, so corresponding to the key 1 you have an entire list. Okay, which is okay. I never said you cannot have a list here. Okay, so that is okay. Yes, the key should be unique. We will talk about that now. Now how do you print the keys? You just write name of the dictionary and dot keys. So if you write name of the dictionary dot keys, you will get this, all the keys that you have in the dictionary. So I have employee 1, employee 2, employee 3, all of that will be printed here. Okay, similarly you can write name of the dictionary dot values also. If you do that, you will get all the values. Okay, all the values that are present, you will get that as output. Okay, now if you cannot access, now the question to be asked is, I cannot access the values by their index, right? We saw that you cannot use indexes in a dictionary. Then how do I access the values? Let's say I have to access Raj. How do I access it? You can access the values using their keys. Okay, you can use the keys to access the values. So for example, in a similar way as you wrote in a list, you can write y of employee number 1. So employee number 1, the value corresponding to this key is Raj. So you will get Raj as the output. Okay, so you can write name of the dictionary. So whatever is the name of the dictionary, and you can write the key. Okay, this will give you the corresponding value. This will give you the corresponding value to that key. So this is how you can access values from a dictionary. Okay. Similarly, you can change the values also. So let's say, what do I write here? I have written Y of employee number 2. So remember, employee number 2 is Vijay for me right now. But what did I write here? I wrote employee number 2 is equal to Suresh. Now when I print Y, you see employee number 2 is Suresh now. It is no longer Vijay. What does this mean? This means that the values in a list are mutable. Okay, we just discussed about mutability, which means values in a list are mutable. Okay, these are very important things which are asked in interviews. Okay, guys. So values in a dictionary are mutable. Okay, which means they can be changed. Yes, Amit, that is correct. The output of y dot keys is a dictionary, is a list. Okay, so how can you check the data type of something? You can check the data type of something by just writing type. Okay, so for example, let's say I want to know what is the data type I'm getting here. What is the output here? I can just write type. So type is the command that you use. So I can just write type of it and then see what is the data type. So let us print this. Oops, I made some mistake. Okay, I forgot a bracket here. So it gives you, no, that is not a list. It is something called dictionary keys. Okay, it is not a list, but these are very similar to a list. Okay, they are called dictionary keys. So these data types were not present in Python 2.7. In Python 3.5, they have introduced a lot of new data types. Okay, these small data types. But don't worry, this is very similar to a list. This is dictionary keys. The class itself is dictionary keys. Okay, so the keys, the values of a dictionary, they are mutable, which means the values of a dictionary, they can be changed. So if you have a dictionary, let's say, if you have a dictionary X of, let's say 1 comma 2, let's say this is a dictionary, and if you write X of 3 is equal to, let's say 5, then if you print your X once again, if you print your X once again, what you would get is, you will get 1 is to 2 as before. This will be the same, and here you will get 5. So this will be your new dictionary. Okay, so this shows you that the keys of a dictionary are mutable. Okay, sorry, the values are mutable, not the keys. So Anil wants to update the list inside the dictionary. You can in a similar way. So you can write X of 3, you write something else. So I'm updating the value itself, right? This is what I did. I updated the list within this dictionary. I updated it with 5. If you want to update with something else, you write something else. So you write 3 here. Then instead of 1 and 2, you will have 1, 2, and 3. So in a similar way, this is what I am doing, right? I am also updating it with a new value. If you want to update with just one single additional element, write one single additional element and it will get updated. Okay, And if you want to delete any element, you just write the delete function. So you just write delete name of the dictionary and whichever you want to delete. So employee number 3, let's say I want to delete employee number 3, you just write delete name of the dictionary employee number 3 and it will be deleted. So I no longer have employee number 3, I just have 1 and 2. Okay. Now one important thing to note here is, and this is very important, okay, this is one of the key characteristics of a dictionary, okay, which is this. So what have I done here? I have given the first key as K1 and the first value as V1. The second key is K2. The second value is another dictionary. Okay, the second value is another dictionary, which is perfectly okay. So it runs. Now what am I trying to do? So I'm trying to write y of K2. So y of K2 will give me this particular dictionary. Okay, if I write y of K2, I will get this entire dictionary. Okay, and then if I write again 1, that means I am accessing this key with, so this is a nested dictionary. Okay guys, this is a nested dictionary. So see how am I accessing individual elements from a nested dictionary, and then I am updating it. So y of K2 will give me this entire dictionary. Okay, then if I write y of K2 and then again 1, that means it will give me this particular list, and then I am writing 0, that means it will give me the first index, which is this 1, and I'm updating it with the value a. So instead of 1, I will get the value a, which is what is happening here. Okay, I'm getting the value a instead of 1. So whenever you see a problem which deals with something which is nested, so for example a nested list or a nested dictionary, how you have to approach that problem is break it into small pieces. Break that problem into small pieces and analyze each piece one at a time. That is how you will be able to deal with that problem. So always remember this, break it into small pieces. Don't get scared when you see a nested list. It is very simple. You just break it into small pieces. Okay. Now this is what I was trying to say. Now what have I written here? I have written dictionary and I have written name here. So what this name, I have passed it as a list, and then I have Zara here, age I have 7. So now when I run this, I get an error. What error do I get? I get type error, unhashable type list. So what does this mean? This means that the keys, they must be immutable. So the keys of a dictionary, they must be immutable, which means they cannot be changed once they are assigned. Okay, so remember this is a key characteristics of a dictionary. The keys of a dictionary, they cannot be changed once they are assigned. So any data type which can be changed cannot come as key of a dictionary. Okay, I'll repeat what I said. The keys of a dictionary, they cannot be changed. So any data type which can be changed, it cannot come as a key of a dictionary. Okay, because that will violate the property of a dictionary, that keys cannot be changed. So that means lists, what are lists? Lists, they are mutable. We have seen that lists can be changed. So you cannot have a list as a key of a dictionary. Okay, so to write it in other words, let me write it in other words. In other words, for a dictionary, you have keys, they are immutable. Okay, which means cannot be changed. Okay, they cannot be changed. Values, they are mutable. So values, they are mutable. So that means you cannot have lists or dictionaries or another dictionary as key. This is not allowed. Okay, so this much you will have to remember. Because lists and dictionaries, they can be changed, they are not allowed as keys because keys must be immutable. Okay, so that is why you get this error. So when I pass name as a list, as a list in place of a key, I get an error. I get unhashable type list. Okay. You can have anything else. You can have a list as the value, but you cannot have a list as a key. Okay. And somebody was asking, can we have duplicate keys? You can have duplicate keys, but the old value will be overwritten. So I have one example here for duplicate keys. Where is that example? Let me see. I had one example here. Okay, let me write down an example. So let me insert a cell here. So how do we insert a cell? Let's say I want a line between these two. I will go to insert and insert cell below. This will insert a new cell here at the in between the two. Okay. Now let's say I define a dictionary. So let's say I define a dictionary called temp, and I have, let's say, 1, and I have 112 as the value. Then next I have, let's say, I have key as the key, k as the key, and I have a list as a value 1, 2, 3. And let's say once again I give 1 as the key, and I give new value as the value. Okay. So let's say this is a dictionary that I have. So what have I given here? I have given two keys as the same one. The first key is 1, and the third key is once again 1, but it has a new value. Okay. Now let's see what I get when I print this. I will write print temp. When I run this, so see what happens here. This previous value is overwritten. Now I no longer have this 1 comma 12. Okay, I no longer have 1 comma 12. Instead of 12, I just have new value. Okay, now do you understand? I think Sinoj asked this question, right? So Sinoj, did I answer your question? Or in other words, if you write print temp of 1, you will just get new value. Okay, you will get new value. So the old value is lost. This 12 is lost because you have given a new value at the same key. So the old value is lost. Okay, so this much you'll have to remember. So don't worry, we don't use dictionaries a lot in data science. We will mostly be using a data type called data frames, which we will come across later. So by end of this class or by tomorrow, we will come across a data type called data frames. That is what we use almost 90 to 95% of the times. Okay. So quick revision. Let's do a quick revision for dictionaries now. What did we see for dictionaries? We saw that dictionaries, they always have a key value pair. Okay. Dictionaries will always have a key value pair. So keys, they are immutable. Okay. That means once assigned, they cannot be changed. Values, they are mutable. Okay. Keys, you cannot have lists and other dictionaries as key. Okay. For value, there is no restriction. Okay. For values, there is no restriction. You can have any data type as your value, but keys, you cannot have list and other dictionaries as key. Okay, so Sijo is asking, can we remove a key from a dictionary? Yes, you can. So you can use, for example, the delete function. So here I have, so if you delete the value, the key automatically gets deleted. Okay, see Joe, because the key itself cannot exist without its value. It has to be a key value pair. So if you just delete a value, the key automatically gets deleted. So for example, see here, what did I do? I have deleted empty 3. So this employee number 3 I have deleted, and you see the key also gets deleted, because a key cannot exist independently. It has to have a value also. So you delete a value, you delete a key. Okay. So guys, let's take a break at this point. Let's take a 10 minutes break. Okay. Let's resume the class at 9:50. No, Amit, a key cannot have a null value. Okay, a key is like a address of a dictionary. It cannot be null. Okay, you cannot have a null value for a key. For a value you can have, but not for a key. It's like a address in memory. It cannot be null. Okay. Okay. So let's see another couple of data types. So we have around 3 or 4 more data types to be seen, but we will only see 2 for today, and we will start a little bit of statistics also today. So I'll try to keep the classes a mix of coding and statistics so that it is interesting. If I just teach data types for the entire duration, it might get a little boring. So we will see another couple of data types, and then we will move to the very basics of statistics. Okay. And the remaining data types we will see tomorrow. Okay, so let's see the next data type, which is tuples. Okay, tuples are the next data type that we will be looking at. So what is a tuple? A tuple is a sequence of immutable Python objects. So the word immutable, now you know what it means. So the tuples are immutable, which means they cannot be changed. So tuples are sequences just like lists. The difference between tuples and lists are tuples cannot be changed, unlike lists. Okay, so how do you define a tuple? We define a tuple using first bracket. Okay, so this is a tuple. This is a tuple. X is equal to 1, 2, 3. This is a tuple. If I write x of 0, I get 1. What does that mean? That means indexing. So they are ordered. Okay, so let me write it down here. This means tuples are ordered, that is, they support indexing. So this is one question asked in interviews. What is the difference between tuples and lists? Okay, so tuples are ordered just like lists, but tuples are immutable, unlike lists. Lists, the values in a list can be changed, but the values in a tuple cannot be changed. So if you write x of 0 is equal to 4, for example, so x of 0 is 1 here, right? If you write x of 0 is 4, you get an error. And what is the error? You get tuple object does not support item assignment. So the error is very explanatory itself. So you just telling you that tuple objects, they do not support item assignment. Okay. Okay, so that's all about tuples. So where are they used? You may ask, where are tuples used? So tuples you can use to assign anything which you don't want to get changed. So for example, banks may assign tuples as the account numbers. So any person who has an account number with a bank, the account number never changes, right? The account number will be the same as long as the person is a customer for the bank. So the account numbers can be declared as a tuple or can be assigned as a tuple so that they are never changed and hackers are not able to change it. Okay, so this is one application of tuple, for example. Tuples are very simple, not complicated. In fact, all the others are also simple. So if you just do revisions a few times, you will realize they are very easy to understand. Okay, there is nothing complicated here. Next, let's see sets. So what are sets? A set is unordered collection of data type. Okay, so unordered means they do not support indexing. That is iterable, immutable. So they are immutable also. Okay, so the elements of a set cannot be changed. Okay, so remember these sets, they are both unordered and immutable. So for example, let's say if I define a set like this, X, and they are also defined using curly braces just like a dictionary, but they do not have key value pair. Okay, real elements like lists, but they are defined using curly braces. So I have defined a set here X 1 2 3. When I print it, I get 1 2 3. Now once again I define a set which has these elements. When I print them, I get this element. So you see the duplicates are removed. So that is the advantage of sets. Sets will never have duplicate values. It will only have unique values. Okay, it will only have unique values and they are unordered and immutable. So you cannot access individual elements by their index and you cannot change them as well. So for example, I have defined a set here, one, hello, and then inside this set I have a tuple. So these two are tuples, as you can see what we learned previously. So this is a tuple. I have two tuples inside this set. If I print them, I will get 1 2, okay, which is this tuple, the last one. Then I have 1.0, which is this. Then I have hello, which is this, and then I have 1 2 3. So the order is not important here because tuples anyways they are unordered, so it will just print in some order. Okay, the order is not important because they are not arranged with respect to indexes, they are just randomly put. And then you have yeah, so if you so right now this is a set. If you print it, you get the same things again. So you notice that though you had 1.0 here and again 1.0 here, the duplicates, these are not considered duplicates. Why are these not considered duplicates? Because this is an individual element and this is a tuple. Okay, so it will only delete elements which are all individual. So for example, here I have 3 ones and all 3 ones are similar, so that is why I deleted 2 of them and kept only 1 of them. But here they are different. This is a single element and this is a tuple, so it will not delete this one from this tuple because it will compare this entire tuple with this one, and then it will see that they are different, they are not same, so the unique values will be printed. Did you get the point, guys? Can't hear, guys, can you hear me? Okay, then here there are some codes how to add elements to a set and all. Okay, so how you can add elements to a set. So these are not very important, so I'll not go into them. These are very rarely used, so we don't have to go into them. If you try to access individual elements from a set by their index, so this is what I'm doing. I have a set and I'm trying to access elements by using the index. I'm getting an error. What is the error? Set object does not support indexing. So the error itself is very explanatory. It tells you that set objects cannot be indexed. Okay, so they do not support indexing is what it is telling you. Then I have some commands here which tells you how to delete and how to add elements to a set, which is not very important, so I'll not go into this. Okay, these are not important at all. I have never used this in the last 5 years. So last 4 to 5 years I have been using Python. I have never used this, so they are not at all important. Okay, so that's all about sets and tuples. So we have seen 4 data types. Let's do a revision of all the 4, and then we will move to the loops in Python. What are the different loops that are there in Python? Okay, so I'll start from the last, which is set. So these are the data types, and these are the properties of the data types. Okay, so the last one that we saw was a set. Okay, so what are sets? Let's talk about, so when I say properties, I'll talk about mutability and indexing. Okay, these 2 properties mostly I'll be talking about. So sets, are they mutable or are they immutable? Yes guys, sets, are they mutable or immutable? What did you see? No, they are immutable, Naresh. They cannot be changed. Okay, they are immutable. Okay, sets are immutable. And are they ordered or are they unordered? Can you access individual elements from a set by using its index? No, you cannot. So I should write they are unordered. And what is the additional property? They have only unique elements. They will always have only unique elements. Okay, this is the property of set. Then next, what did we see? We saw tuples. Now let's see tuples with respect to these 2 properties. Are they mutable? Are they immutable? Yes, they are immutable. So tuples are immutable. Are they ordered? Are they unordered? Yes, they are ordered. We can access individual elements using index. Okay, they are ordered. Okay, and they are defined using first bracket. Then next, what did we see? We saw dictionaries. Now they have key value pairs. Dictionaries will always have key value pairs. So, and defined using square brackets. Key value pairs are separated using colon. Are they mutable or are they unmutable? Immutable. So I'll have to write separately. Keys, they are immutable. Okay, the keys are immutable, but the values are mutable. Okay, and what about the, are they ordered or unordered? Dictionaries, can you use indexing there? They are unordered. Okay, they are unordered. And then the last one, which is lists, or the first one rather, these are they ordered or unordered? Are they mutable, unmutable, immutable? So these are mutable, you can easily change, and they are ordered as well. So this is what we have seen about the 4 data types in Python. Okay, so you may get a lot of questions based on these properties. Okay, so based on these properties you may get questions in interviews, and this is especially important for people with less than 3 years experience. Okay, so people with less than 3 years experience, for them such questions are very commonly asked. Maybe not for people who have around 5 years or more than 5 years experience, because these are very small questions. These will not be asked to people who are senior, but people who have just begun their career, who have less than, let's say, 2 or 3 years experience. For them, these questions are very important. Okay, these kind of questions you can expect in interview. Not required. I did not declare, right? I did not declare any variable before using it. See, I directly wrote x is equal to 1 2 3, a list 1 2 3. I did not declare that x is a list, and then I did not initialize it. I directly used it. Okay, so that is the advantage of Python. It is different from C or C++ in that manner, that you don't have to first declare and then initialize and then use it. You can directly start using it. So it is much easier. So now let us see some basic statistics before we go to loops. Okay, so we'll talk about very basic statistics. Let me open a new page. Okay, first let's talk about what is a histogram. Okay, we'll talk about a plot which is very popularly used. You'll be using this a lot, which is called histogram. Okay, so let us see what is this. So let's say if I tell you that I have 20 students in this class. Okay, I have 20 students in this class, and let's say I want to study the age of the class. I want to study what is the age of the students that I get. Okay, so what are the different ways of studying this age? What are the, in how many ways can I study this age? Let's say somebody asks me what is the age of this particular class. How can I give this information to that person? So the way I can give this information to this person, to the person who is asking what is the age of your class, is in many ways. The best way is to use descriptive statistics. Okay, so first we will talk about the different types of statistics that we have. The most commonly used type, and this is the most easiest one, which you probably have studied in your schools, is called descriptive statistics. So what is descriptive statistics? Descriptive statistics talks about parameters which are used to describe a population. Okay, so when you have a population and you have to study that population, or when you have to describe that population to somebody, you use certain parameters. So all those parameters fall under descriptive statistics. Okay, so parameters which you have very commonly seen. So example, what are the parameters? Example is average, or the median, or the mode. Okay, or standard deviation. We will see what standard deviation is. We will see this. Okay, but these three parameters you would have seen in your schools. So these all fall under descriptive statistics because they are used to describe a population. So right now our population is all the students in this class, 20 students. Okay, so that is our population. And how would I describe my population? Let's say if somebody asks me what is the age of this class, I will not tell him 20 different ages, because all 20 of you might have different ages. I will not tell that person that this is the age of my class and I'll start telling him 20 numbers corresponding to age of everybody. That would be meaningless, right? I cannot give him, if I have 100 students in the class, I'll have 100 numbers. So I will not give somebody 100 numbers that okay, this is the age of the class. So what will I do? For the information to be easily understood by the person, I will probably give him the average, that okay, this is the average age of my class, and that will be good enough information for him. So let's say I can tell him that the average age of my class is, let's say, 26 years or 28 years or whatever. Okay, I'll just give him the average age, or I can give him the median age also. I can tell him that this is the median age of my class, or I can tell him the mode if required. So mode is the most commonly occurring age. So let's say I can tell him that I have mostly people with 5 years experience and whose age is around 28. So 28 is the mode, which means most of my students have an age of 28. Are you following, guys? Okay. What is median? Median represents the percentile. Okay, it represents the percentile. Median is the 50th percentile. Okay, the number which is right in the middle. So if you have, let's say, 1, 3, 9, 11, if you have, and let's say 13, if you have 5 numbers, what is the median? The median is the middle, the centermost number, which is 9 here. So how do you find the centermost number? You first arrange in increasing order and then you find. Okay, always remember this. People often forget this. Okay, you first sort the numbers and then you take the middle one. Okay, if I give one more number, let's say 15, then what is the median? What is the median of these numbers then? Because I don't have a middle number now, right? I have 3 this side, I have 3 this side. Then what number will be the median? It will be the average of these two numbers. Okay, so 9 plus 11 divided by 2, which is 10. Yeah, so this is the median, which is right in the middle, which is the average of these two numbers. So this is how you find the median. Okay, so the average of the number, the median of the number, or the mode of the number. Mode also everybody understands. So these are very popularly used to describe a population, and these fall under descriptive statistics. We will see what standard deviation is. We will see that today. So after some time we will see that. So that is the standard deviation. Okay, so these three parameters are very popularly used to describe a population. But whenever you use these three parameters, whenever you use them, you lose some information, right? So if I tell somebody that the average age of my class is 28 years, I'm not giving him a complete information, because that is the average age. I don't know what is the maximum age. I don't know what is the minimum age. I don't know, do I have people who are, do I have more people who are younger, or do I have more people who are above 30? I'm losing a lot of, just use the average or the median or the mode. I lose a lot of information. So that is where histograms become very important. Okay, because whenever you use these parameters, you lose some information. Okay, you lose some information. To avoid that, what we can use a histogram. Now let us see what a histogram is. So let's say I collect everybody's age. I collect everybody's age in this class, and let's say it falls like this. So 23, 21, 28, 32, 36, 29, 30, and so on. So let's say I have collected everybody's age, and this is how the numbers look like. Now, how will I draw a histogram for it? So I draw it like this. Okay, a histogram will have a x-axis and a y-axis. Okay, the x-axis will have the variable that I am plotting. So what is the variable I am plotting here? I am plotting the age, so I will write age here. Okay, and what will be the y-axis? So a histogram is always drawn for only one variable. Okay, you do not draw it for two variables. Okay, so you do not have one x-axis and something else on the y-axis. So it's not like age here and income here. This is not a histogram. Okay, this is a scatter plot, which we will see later. So histogram is always drawn only for one variable. So that means we are talking about one quantity only. Here we are talking about age. Then what should be the y-axis? What do you think, guys? Any guesses you want to make? I have already given age as the x-axis. What should I give on the y-axis then? Yes. I will give the frequency. Okay, I will give the frequency. What is frequency? Just the count. Okay, count of what? So let us see count of what we will give here. So what do we do in histogram? We divide the x-axis into smaller pieces. Okay, so let me divide it into, let's say, 20 to 25, then 30, then 35, let's say 40, and so on. So I have divided it into five, into age groups of five, right? In age of five blocks I have divided it. Now what will I do? I will count how many people are between 20 and 25. I'll count in this information that I have. So I will see everybody's age and I will count how many people have age between 20 and 25. Let's say, let me draw histogram only for these numbers which I have written here. Okay, so how many have between 20 and 25? This is 1, this is 2. Okay, I have two numbers. So the height of this will go till 2, which means the frequency will be 2. This is 1, this is 2, so this is 3. So the height of this bar will be till 2. Okay, because there are two people who are between 20 to 25 years old. Similarly, now I will see with 25 and 30. How many people are between 25 and 30? So there is one here, there is one here. So again 2. Okay, this one also 3. So the height of this will go till 3. Okay, so this will be the height till 3. Now similarly between 30 to 35 I have only 1, 32. So the height of this will go till 1. Okay, this is the height. And between 35 and 40 is also 1. So the height of this also will be 1. So this is the histogram. This is the histogram for age distribution of this class. Now if you look at this diagram, you don't lose any information. See, I can exactly know what is the age of every individual in this class. So I know that there are two people who are between 20 and 25. There are three people who are between 25 and 30. There are one people each within 30 and 35 and 35 and 40. So I don't lose any information. So this is the advantage of using a histogram. Okay, do you follow, guys? Any doubts on this? We'll be using this a lot. Okay, now you might ask, why did I take a block of 5 years only? Why did I not take something else? You can take something else. Okay, so you can take, let's say, 2 years also. So you can draw another histogram where you have, let's say, 20 to 22, then 24, then 26, 28, 30, 32, and so on. Then your histogram will look slightly different. Okay, then your histogram will no longer look like this. It will look slightly different. So you can change that. There is no fixed rule that you should have 5 years or 10 years. It depends on the data. The more granular you go, the more detailed information you get. So if I look between 2 years, I will get more detailed information. So here, for example, if I have a gap of 5 years here, I do not know how many people were between 20 and 23 and how many were between 23 and 25. I know the total, that there were two individuals between 20 and 25, but I don't know how many were between 20 and 23 and 23 and 25. I don't have that information. Okay, because I am looking it at an aggregate level. But if you go more granular, you will have more detailed information. Let's say if you look only with 1 year, let's say 22, 23, 24, and so on, then you will have more detailed information. So the more granular you go, the more detailed information you have. Okay, the less granular you go, the more aggregated information you have. Okay, so depending on your scenario, so when we will be doing a lot of case studies, there depending on our scenario, we will be varying the parameter. So this parameter, this break, this gap that we are giving, we will be varying this. So we can do this in Python very easily. There is just one function that is used to draw this, and you will be varying this parameter depending on what kind of information you want. Okay, so this is about the histogram. Any questions on this? I'll pause for 2 minutes. Think about this, guys, and tell me if you have any questions. Okay, so Hima is asking in which scenarios do we use histogram? So we use histogram whenever you have to study a variable which is quantitative. So remember, age here is quantitative, right? It is a quantitative variable. So we use a histogram whenever we have to study a quantitative variable. Okay. So one example is age here. So you have to study the age of a class. You can use a histogram. Let's say you have to study the income of a city. If you have to study the income of a city, you can draw another histogram for it. Okay, income of a city. Let's say Flipkart has to study, or Amazon has to study how many orders does it get with respect to days of the week, for example. So let's say it will start from Monday, Tuesday, Wednesday, all the way till Sunday. So how many orders does it get? Let's say it gets 10,000 orders, 11,000, 12,000. Sunday it gets 30,000 and so on. So it can plot as a histogram also how many orders it gets. Okay, because we are looking at quantitative variables, we are looking at quantities. So for these quantities we draw histograms. So we will see this a lot later. So don't worry about them now, where it is used and all. We will see this once we start with machine learning. We'll be using a lot of histograms there. Okay. Right now, just understand how is a histogram drawn? What information do we get from a histogram? We will see where they are used as the class proceeds. We'll be using them a lot. So then it will become pretty clear to you where they are used. But remember, they are always used only for quantitative variables. You cannot use a histogram, for example, for gender. Okay, gender is not quantitative variable. You will just have male and female. For that, you can use a bar plot. A bar plot is different. Okay, so for example, for gender, you will have bar plot that, okay, I have these many male and I have these many female. Okay, this is again the frequency, and this is gender. This is a bar plot. This is not a histogram. Okay, this is a bar plot. This is different than a histogram. In histogram, you will have a quantitative variable. Okay, a variable which can take decimal values, for example. Okay, which have quantitative meaning. So 2, 1, and all those things. Male and female, for them you will draw a bar plot which is different. This is a bar plot or just a frequency plot. These are not histograms. Okay, histograms are only for quantitative variables. Just remember that. Okay, now let us study about some distributions. Some distributions that are very commonly seen in businesses or in nature as well. Let us see some distributions, or let me write it, probability distribution. Okay, probability distributions we will look at. So the first distribution that we will look at is uniform distribution. Okay, the first distribution that we will talk about is called uniform distribution. So anybody would wants to make a guess, how does it look like? Bell shaped? No, that is a normal distribution, Bharti. What does the word uniform mean for you? What does the word uniform mean? So look at the word uniform. Yes, uniform means a straight line. It doesn't change. It is uniform. Okay, it means a straight line which is uniform. So this is what a uniform distribution means. It means that the quantity doesn't change. It stays flat. Okay, it stays flat. So all these probability distributions are studied using histograms. We use histograms to study them. Okay, so the histogram for a uniform distribution will look something like this. So you have the variable here, and once again you have the frequency here. This is what you have always in a histogram. Now for a uniform distribution it would look something like this. Okay, it stays flat. See, it doesn't change. It doesn't change. It is uniform. Okay, so this is what a uniform distribution means. That means it doesn't change. So let's say this can happen with the age distribution also. Let's say I have 5 students who are between 20 to 25. I have 5 students who are between 25 to 30, and I have again 5 students between 30 to 35. And then if I draw the histogram, let's say this is age and this is the frequency, and I have taken blocks of 5 also. So this is 20, this is 25, this is 30, this is 35, and so on. So how much the height of this will be? 5. The height of this again will be 5. The height of this also will be 5. So see, this is a uniform distribution. So what does this tell you? This tells you that I have equal number of students between these age groups, between 20 to 25, 25 to 30, and 30 to 35. At each place I have 5 students. So this represents a uniform distribution. It doesn't change. But previous example which I gave, it was not a uniform distribution because it was changing. It was non-uniform. It was changing. But now I have a uniform distribution. Okay. So this is what is a uniform distribution. Do you get it, guys? So one question for you. Let's say you have a bag of marbles. You have a bag of colored marbles. Okay. There is one marble which is blue, or let's say there are 3 marbles which are blue, 3 which are red, then another 3 which are pink, and let's say another 3 which are green. Okay, so these are the marbles that I have in a bag. Now you close your eyes and you pick one marble from this bag. Okay. Okay, and similarly you pick remaining marbles from this bag, and you replace it back. Okay, so let's say what you are doing is you are closing your eyes, you are picking one marble from the bag, and you are noting down the color, and then you are putting the marble back in the bag, and then you are repeating this process thousands of times. Okay, so thousands of times you are repeating this process. How would the histogram look for this? How would the histogram look for this? So let's say 1,000 times, 1,000 times you have drawn marbles from this bag. Okay, how would the histogram look like, where here you have count, and here you have, let's say, the colors. Let's say you have red, blue, green, and pink. If 1,000 times you have noted down, yes, it will look uniform, it will look almost uniform. Okay, because you have the same number of marbles, right guys? You have the same number of marbles, so the probability of the green marble is how much? It is 3 divided by 12. The probability of the pink marble is also the same. The probability of the red marble is also same. Probability of blue marble is also same. So each marble has the same probability. Same probability in the sense, so this quantity is nothing but probability. If you see this quantity guys, it is nothing but probability. In other ways it is probability because it is frequency. Okay, so if you draw this, if you draw the histogram for this, it will look uniform, it will not change, because each color has the same, it will appear the same number of times. Total, if it is 1,000, each color will appear the same number of times, so you will have around 250 times, each will appear around 250 times. Okay, or you can say the probability is 250 divided by 1,000, or 1 by 4. That is the probability of each marble appearing. Okay, yes, this is more of a bar plot, this is more of a bar plot, but this also is like a uniform distribution. Okay, because we are not representing, so you can say this is because we are representing the quantity also, right? Because we are representing the counts. Okay, but what I'm trying to say, the point I'm trying to make here is that each of these examples which I gave, they follow a uniform distribution, they are not changing, they are the same. Okay, so how do you study any probability distribution? You study any probability distribution by looking at their histogram. And now you know how to draw a histogram. We will see how to draw this in Python, it is very easy, but right now you learned how to draw a histogram manually. Okay, now let us see another distribution. Let us see the next probability distribution, which is called normal distribution. Okay, this is called normal distribution. Now anybody would want to make a guess, how does it look like? Once again I will draw the histogram for this. Now how does it look like? So this looks like a bell curve. Okay, it will look something like this. Okay, it looks like a bell curve. Yes. Now why is it called normal if it looks like a bell curve? It is called normal because it is so popularly seen in business as well as nature. Okay, that is why it is called normal, because it is perfectly normal to see a histogram like this for any quantity, for most of the quantities. Okay, so for example, you take the height of any bunch of people, take the height of any bunch of people, So let's say you have, let's say collect thousand people and ask them their height. You will find that a few people are very tall, right? A few people will be very tall, so they will fall here. So let's say we are talking about height. Okay, it starts from, let's say, 5 feet, goes till 6 feet. So you will find a few people who are very tall, so the height of this bars will be less, because only a few people will be very tall, right? Not all of them will be 6 feet. Similarly, only a few people will be very short. Okay, let's say we are talking only about one gender. Okay, let's say we are talking about one gender only. So a few people will be very short, a few people will be very tall, but most of them will have somewhere close to the average, right? So the bar will increase as you go towards the middle. Okay, the bar will increase and then it will start decreasing once again. Okay, so what I have drawn here is nothing but I have drawn a curve over the bars. I have drawn a curve over the bars, so it is looking like this. I have not drawn individual bars, but I have drawn a curve over them. So this is a normal distribution. Why is it called normal? Because it is very common. Okay, so for example, height, weight, okay, lot of other things, they follow a normal distribution. This is why it is called a normal distribution. Now this is one of the most important distributions in statistics. We will see why this is the most important. Okay, because we have a lot of statistical theorems based on this distribution. So we will study this in a lot of details. So almost 4 to 5 hours we will be talking about just normal distribution. Not today. Today is just the introduction. Later in the following classes we will talk in details about a normal distribution. But right now just understand what is a normal distribution. Okay, and this is also known as bell curve. So this is what is used for most of the companies. They use for their employees appraisal. So the appraisals that happen in companies, in most companies it follows, they try to fit a bell curve over the employees performance. Okay, so some of the employees fall here. So these are the best performing employees. Some of the employees, they fall here. They are the worst performing employees. So these are the employees who get the pink slip basically. These are the employees who are the best, and these are the employees who are the average ones. Okay, so their numbers is a lot. Okay, so you would have seen in wherever you work, whichever companies you work, most of the people, they get the average rating. So this is where they lie. You see, this forms most of the total area, right? This forms most of the total area. So most of the people get the average ranking, a few people get the best ranking, and a few people get the worst ranking. So that also follows a normal distribution. Okay, so this is what is used in company review or ratings, the infamous bell curve. Okay, so what we saw what is a histogram, then we saw what is a uniform distribution, and then finally we saw what is a normal distribution. We will talk about them in details. Now in a normal distribution, so if I say this is the probability, let's say instead of frequency, if I call it probability, you will see the average. Where will the average lie in this distribution? So in this distribution the average will be right in the middle, right? Because it is symmetrical, so the average will be right in the middle. So what do we see here? We see that most of the data is near the average, right? Most of the data is located near the average, and at the extremes you have very few records. So the height represents how many, right? The height represents the quantity or the probability. So at the extremes you have a very small probability, and somewhere close to the average you have most of the people lying. Most of the data is situated near the average, and at the extremes you have very few records or very few data. Okay, doubts on this? Any doubts on this page, guys? Okay, now let us move to what is a standard deviation. Okay, this is where we'll end the stats part today. We'll see about standard deviation and we'll move back to Python. So what is standard deviation? This is a very important quantity. Okay guys, this is a very important quantity for statistics as well as for data science. So let's see what is standard deviation. So let us first understand what is the need of standard deviation. Why do we need a quantity called standard deviation when we already have the average, the median, okay, the mode? Why do we still need another quantity called standard deviation? So let's say let's say we are talking about age of this class. Okay, let's say I have 10 students and all 10 of them are 30 years old. So how would the histogram look like? The histogram would look something like this, right? Where this is 30, this is the frequency, and this is age, right? This is how it would look like. What is the average age of the class? Average or X bar, what is the average? If I have 10 students, all of them are 30 years old, the average is of course 30, right? Now consider another situation where I have 5 students who are 25 years old, and I have, let's say, 5 students who are 30 years old, and I have 5 students who are 35 years old. Okay, now how will the histogram look like? The histogram, I'm directly drawing a curve for that. Instead of drawing a bar like this, I'm directly drawing a curve. It would look something like this. Okay, where this is 30, this is 35, and this is 25, right guys? I know you will not you'll have spaces here. I've just plotted a curve over it, so it would look something like this. Now what is the average age? Average or X bar here, what would that be? Yes, once again 30, right? Once again 30. So that means if we just look at average, no, it would not be a normal. So Arun, it is not normal actually. So that's what I told you. I don't consider this. It is not normal. I have just put a curve on top of the bars. So it looks like it is normal, but it is not normal. It is actually 3 independent bars like this. Okay, it is 3 bars like this. Yeah, it is like this. But if I draw a curve on top of this, it would look like this. It would look something like this normal. That is what I had drawn. Okay, because if you plot a curve, the curve would touch all of these. Okay, this is how a curve goes. Then it will look like this. Anil, during the class, I don't think it is possible. Okay, during the class, it is not possible to get some practice session. You can do that after the class because we have limited time, right? So let us use this time to learn things, and after the class you will always have enough time to practice. And whenever you have a doubt, you can use the WhatsApp group to ask questions, or you can mail me also. Okay, so that is how because it is not possible if I have 20 students and if I give you guys something to do, how will I track what you are doing? Yeah, we will have that, of course. So this is the basic. This is the first day, guys. You will have a lot of practice sessions later. A lot of assignments will be given. Yes, Arun, that is correct. Then it would more or less look like a normal distribution. Okay. So I shortened the example a bit. So I just took three different ages. Okay. So now also you have the average age as 30 in this case, and you have the average age as 30 in this case also. So if I just talk about the average, both these two scenarios would be the same for me, right? If I just talk about the average age, both these scenarios would mean the same for me. But we can clearly see that there is a difference. Okay, we can clearly see that there is a difference here. Okay, so how do we understand that difference? How do we read that difference? Something which is always 30 and something which is sometimes 30 but sometimes 25 and sometimes 35 also. So we read that information using the quantity called standard deviation. Okay, the deviation, you see the word deviation, that is what is the deviation, that how much is the quantity varying. Okay, so let me give you another example to explain why do we need standard deviation. So let's say you are a stockbroker, or let's say you are a retail investor, who somebody who buys and sells stock. Okay, and let's say I give you the stocks of two companies. Let's say this is the stock of, let's say this is Infi, and this is the stock of, let's say, TCS. Okay, so I've given you stocks of two companies, and this is the price. This is the price of the stock, and this is of course the frequency. So I have drawn the histogram basically. Okay, and let's say I have two types of investors. The first investor is who is ready to take risk, and the other one, he does not want to take risk. So he does not want to take risk. Okay, so in which stocks will these two invest? Looking at this plot, what do you think? So let's say you have an investor who is ready to take risks. In which stock should he invest? Infosys or TCS? Okay, Bharti says Infi. Hima says also Infi. Vikram also. Anybody who says TCS? Or why do you think you say Infosys? Why are you saying Infosys? So you notice here, both the stocks or both the companies have the same average. Yeah, it has a large variance. Least deviation. Okay, I'm yet to teach that, but you are talking the same thing basically. What I will be teaching now. Okay, so if you just look at the average, both of the stocks, they have the same average, right, guys? They have the same average. Let's say 300. So both the stocks have the same average, but we can clearly see that Infosys, it rises more. So Infosys can go, let's say, till 500, but TCS will only go till 400. Okay, Infosys can, the price of Infosys can increase more than what it can for TCS. But at the same time, the price fall also is accordingly. Okay, the price of TCS falls less than that of Infosys, right? It goes only till 200. It cannot go till 100. But Infosys, you can earn a lot in Infosys, but at the same time you can lose a lot also. The price, what if it goes to 100? But TCS price will never go till 100, because there is no height of the bar after 200. But since you are somebody who is ready to take risk, then I think you guys are right. You can probably select Infosys because you are ready to take risk. So here the chance of gaining a lot is high. At the same time, the chance of losing the lot is also there. Okay, but since you are ready to take risk, you will invest in Infosys. Okay, and similarly, on the other hand, somebody who does not want to take risk, for him or her, TCS is a better stock because it is more consistent. It only varies from 200 to 400, not beyond that. Okay, so it is more consistent stock. So I can write consistent stock. Okay, all of you understood this example? Okay, now let me come to the point. Why did I give you this example? Now, how did we decide which stock is better for these two investors. We looked at the histogram and we decided, right? We looked at the histogram and we decided this is nothing but the histogram. Now, but there must be a mathematical parameter also to read the same information. Okay, there is also a mathematical parameter which helps us decide the same information, and that parameter is standard deviation. Okay, that parameter is standard deviation. So which stock has a higher standard deviation? Intuitively, what do you think? Which of these stocks has a higher standard deviation? Infosys or TCS? Yes, exactly. Okay. So standard deviation of Infosys is greater than that of TCS, looking at this data. Okay. So standard deviation, so I think you understood what does it measure? It measures the variation. Okay, it measures the variation. Okay, how much is a quantity varying? Variation or the change, okay, or the inconsistency. Okay, how inconsistent is a quantity? So if you have 10 students in the class, how inconsistent is their age? Is the age always 30, or sometimes it is 28, sometimes it is 32? Is it varying a lot? So that variation is captured by standard deviation. Okay, standard deviation is the quantity which captures that variation in data. Okay, now this is also used always for a quantitative variable, something which is quantity. You cannot draw standard deviation for gender. It wouldn't make sense, right? Somebody who is a male is always a male. He will not vary. There will not be any inconsistency there. Okay, so it is always measured only for a quantitative variable. Now when we talk about variation, we will have to see the variation from something, right? There must be a benchmark. How will you see the variation? Variation from what? Variation means it always has to be with respect to something, right? So here, for example, why did you say that Infosys prices are varying more? Because you did some comparison. Okay, so that comparison is the average. Okay, not the median Bharti, it is the average. In this case, both average and median is the same, but it is with respect to the average. Okay, so let me write it down. It is the variation, change, or inconsistency from the average. So this is the English definition of standard deviation. This is how you would define standard deviation in English. Okay, so more appropriately, let me define it. So this is the definition. Standard deviation is the root mean square of deviations from average. Okay, so this is the formal English definition of standard deviation. We will talk about what is this RMS. Okay, but you are basically measuring how much is a quantity varying from its average. Is it always closer to the average, or is it changing a lot? Okay, so for example, what will be the standard deviation of this scenario? Can you say what will be the standard deviation of this scenario? Yes, exactly. It is zero because it is always constant. It is always constant. There is no variation. There is no inconsistency. There is no change. It is always 30. I have 10 students, all 10 are 30 years old. So it is a consistent or a constant quantity. So the standard deviation is always zero because the average is also zero and all the actual values are also zero. So the standard deviation for this is zero. Okay, for this we will have to find out. So there is a formula that we will discuss now. Using that formula we can find out what is the standard deviation for this. Okay, so let's see what is the formula for standard deviation. So you just have to remember this RMS. Okay, what is RMS? It stands for root mean square. It stands for root mean square. Okay, so standard deviation is the root mean square of deviations from average. Okay, so now let me write down the definition in mathematics. I'll write down the definition in maths. So the best way to remember it is you go from, if you remember this English definition, you can easily get the formula. Okay, how will you get the formula? You start from the right hand side. Okay, you start from the right hand side and you will easily get the formula. So let's start. What is the first thing you get from the right hand side? You get the average. So that means first thing is you'll have to calculate the average. So let me write x bar as the average. So what is x bar? X bar is x1 plus x2 till xn divided by n. Okay, this is how we write x bar. Or if I write in mathematical notations, it will be I goes from 1 to n. Okay, this is how you define x bar. Then what do you get next? You get next as deviations. Okay, the next, if I'm starting from the right hand side, the next letter that I get is deviation. So how will I calculate the deviation? I will take each quantity or each age and subtract it from the average. This is my deviation. So that means if I have, let's say, 3 points, I will take the first point and subtract it from the average. I will take the second point and subtract it from average. I'll take the third point and subtract from average. This is my deviation of first point. This is my deviation of second point. This is my deviation of third point. Are you following, guys? Okay, so that is what I have written here. Instead of writing for n points, I have written in mathematical notation that I xi minus x bar, where I can be from 1 to 10 if you have 10 points, I can be 1 to 1000 if you have 1000 points, and so on. Okay, so next what do you get? Next you get the word s. S means square. So what you will do, you will just square this quantity. Okay, next what do you get? You get mean. So I'll take the mean of this quantity. How will I take the mean? Just divide it by n and you take the mean. Okay, next what do you get? You get root. So what I will do, I will take the root of this quantity. Okay, and I'll have to give here summation of 1 to n because I goes from 1 to n. So this is the formula for standard deviation. So do you think you guys can remember this? Just first remember the English definition and start from the right hand side. Standard deviation is the root mean square of deviations from average. Take the average, find the deviations, square the deviations, then take the mean of it, and then finally take a square root. This is the formula for standard deviation. Any questions on this, guys? Yes, any doubts so far? Okay, cool. So this is how you define standard deviation, and this is the formula. So I will send an assignment where you will have to manually calculate this in Excel. Okay. So later we will see in Python it is very easy. There is a function called SD. So you just write SD and write a list. It will calculate the standard deviation of that list. Okay. But you should remember the formula. Okay, guys. Data science is all about understanding the concepts. Okay. So don't think that you have to do everything in Python. First, understand how you have to do it manually. If you know how to do it manually, you can always use a piece of code to run that. So understanding the maths is important, not the code. Code you can just Google and get the code. Okay, you don't have to worry about the codes. Understand the concepts. Why do you need a quantity? So while you are learning, ask yourself as many questions as you can. That why do I need this quantity? Only if you know why do you need that quantity, you will be able to appreciate that quantity. You will know where to use that quantity, under what situation, under what scenario that quantity will be helpful. So ask these questions. This is what will help you. Not how is a quantity calculated. Anybody can calculate that. Just use a formula, Google, you will get the formula. But understand, why do you need that? What is the necessity of that quantity? In mathematics, you don't just have a parameter. Every parameter, there is a reason behind every parameter. Okay, so try to understand what is the reason for that parameter. So for example, in this case, we saw, why do we need standard deviation? Because we have to measure how consistent is a variable. Is a variable always the same? Is it a constant, or does it keep changing every time? And if it keeps changing every time, how do we measure that change? So here, for example, the stock prices of both Infosys and TCS changes. But if you have to measure which one changes more or which one is less consistent, you need a parameter for that. You cannot always draw a histogram. Okay, so that parameter is standard deviation. Okay, so understand in that way. Ask as many questions as you can to yourself. Okay, I think this is all we will do for statistics today. So this is all that we will do for stats. So let's move back to Python. We have half an hour left. So we'll move back to Python and see a few different stuff in Python. Okay, so this was intentional. I intentionally mixed Python with a little bit of statistics so that the class is a bit interesting. Otherwise, it will become like a software engineering class, which I don't want it to be. Okay, it's not a software engineering class. Okay, so let's come back to Python now. So we have seen the very basic data types in Python. Now let us see how do we create loops in Python. Okay, so it is very simple, just like you have in any other language. So if you know C, C++, or any language, if you have studied a little bit of coding, you will understand this. It is very simple. Guys, just a moment. I'll be back in 2 minutes. Okay, this is not a break. I'll be back in 2 minutes. There's somebody knocking my door. Okay, so let's first see a for loop in Python. It is very simple. So first I have defined a list here. So X is a list which has 3 elements, 1, 2, and 3. Now if I have to print each element individually, I can easily use a for loop for this. So what is the syntax? The syntax is I will write for I in X what is I here? I is just a variable which will keep changing. Okay, I is just a variable which will keep changing. So I'm writing for I in X, and then look at this colon that I have given. So that colon is what is mandatory in Python. So let me explain it here. So let's first see for loop. So how you write is, so for I in, let's say, a list. Okay, so here I is just a variable, and a list is, let's say, a list which exists. So you have a list which exists, and then you give the colon, and then you leave a space here. Okay, what is this space? This is called indentation. Okay, this space is called indentation. So how will Python know that which lines are part of the loop? That is decided by this space. So wherever you have this space given, Python will know that that is part of this loop, and wherever the space is not present, Python will think that it is outside of the loop. So that is why this space is mandatory. Okay, the space is mandatory because that helps Python know which statements are part of the loop, which statements are outside the loop. Okay, so this is why I have given here this gap that you see here. I have given this gap. This is equivalent to one tab space. The moment you press enter, Python automatically will take that space. Okay, so Python automatically takes that one tab of space, and it will print now. The first iteration, the value of I will be 1, so you have 1 printed. In the second iteration, the value of I will be 2. In the third, it will be 3, and so on. Okay, so this is how this for loop works. Now what would happen if I write a print I outside the loop? Can anybody tell me what answer would I get? If I run this, what would I get? So this print statement is outside the loop. So will I get just 3 as the output or something else? Okay, Sinod says I'll get undefined I. Shiva Kumar says error, error. Okay, let's see. Let me run this. I'll get 1, 2, 3 and again 3. Okay, so why did I get this? Let me explain. So your X is 1, 2 and 3. Okay, now when you are iterating, when you wrote for I in, let's say, X, what is the first value of I? The first value of I is 1, right? So 1 gets printed. What is the second value of I? It is 2. So 2 gets printed. What is the third value of I? It's 3. So 3 gets printed. After this, there is nothing left inside X. So it will come out of the loop, right? It will come out of the loop. Now, what was the last value of I it got? The last value was 3, right? So the value of I is still 3, and I have written print I. So it will print 3 once again. Okay, because after it came out of the loop, the value of I was still 3, so it printed that 3 again. Now you understand why do I get this output? Did you follow this, guys? Did you follow why did I get this as the output? Yes, of course, Sinoj. The scope of I is outside of that loop also. Okay, this is a loop, not a function. That happens in functions.
Okay, in functions, the scope of variables defined in a function are limited to that function, but this is just a loop. Okay, the scope will be outside also. Okay, now similarly you have a while loop. So while loop is similar to a for loop. You have to give the indentation here also. Wherever you have an indentation, it means it is part of the loop. Okay, the indentation means it is part of the loop. So I have I is equal to 5 here, and then I have written while I is less than 10. Okay, print I, and then I have given a if condition inside this while loop. Okay, so this is how you give a if condition. For if condition also you will have to give indentation. So I have a double indentation here. Do you see the space? I have double space here. What does that mean? That means that this is inside the while loop and also inside the if condition. Okay, this is what it means. But this has only a single indentation. This has a single indentation, which means it is not inside the if condition, it is only inside the while condition. Okay, so let's see how it goes. In the first iteration, the value of I is 5, which I have assigned here. So right now I is 5. So is 5 less than 10? Yes, so it will go inside the loop. Okay, since 5 is less than 10, it will go inside the loop and it will print 5. So 5 is printed. Next, this if condition will be checked. Is I less than 8? So right now I is 5, so obviously it is less than 8, so it will go inside the if condition and it will print 5 once again. Okay, then it will go to the next line and the value of 5 will become 6 now, because I have written I is equal to I plus 1. So it will, the new value of I will be 6. Okay, so after this it will go back to the while loop. Okay, it will not go back here, it will go back to the while loop. Okay, now 6 is less than 10. Yes, so 6 will be printed. Then 6 is less than 8. Once again 6 will be printed, and 6 will become 7 now. 7 is less than 10. It will go inside while loop, it will print 7. Again 7 is less than 8, so it will go inside the if condition and print 7 once again, and then 7 will become 8. Now 8 is less than 10. Yes, so it will print 8. 8 is less than 8. No, so it will not go inside the if condition. It will directly come here and 8 will become 9 now. So 8 will be printed only once, because the if condition is not true for 8. Similarly for 9 also. So did you understand this, guys? The while loop and the if condition inside the while loop. Any questions on this while loop and the if condition? Okay, cool. Now always remember, whenever you are using a while loop, you must give a condition like this, an increment like this. Okay, so this increment is mandatory. If I don't give this, it will become an infinite loop. Okay, if I had not given this I is equal to I plus 1, I will always be equal to 5, and 5 is always less than 10, so it will keep on printing 5. Okay, it will never stop. So I'll have to basically use the task manager to close this. Okay, so be careful when you're using a while loop. There always must be a condition like this, which at some point of time will be false for this condition in while loop. Okay, only if this becomes false it will stop, otherwise it will continue forever. So this is something which you have to keep in mind when you're using while loop. Okay, otherwise it is fairly simple. This is exactly how you use while loop or for loop in C or C++ also. So it is similar. Okay, now similarly you have if else condition. So if you have to test multiple conditions, so here I have just used if, but what if you have to check multiple conditions? Then you will have to use a else if condition. Okay, if condition 1, else condition 2, and so on. So the short version of that, instead of writing else if, we write elif. Okay, so elif means it's a else if condition. So what have I written here? So remember, what is the value of I? Last I got the value of I as 9. So I is still 9. So in this example also I will still be 9, because that is like the value of I now, unless I change it. So if I is less than 4, it will print this. So since I is 9 for me, it will not print this. This will be false. It will not go inside this if condition. Else if, or elif, I is greater than 4, yes, this is true for me, so it will go inside and print this. So I is more than 4 will be printed. And else means if none of these conditions are true, the last one will be automatically, it will become true. But for me, this second condition is true, so it will print the second print statement. Do you follow, people? Guys, did you follow? Okay, now let us see a few functions. There are a few functions that we can look. So range is one of the functions. So range of 5, what does it print? So range of 5 means it prints out the numbers starting from 0 till 4. Okay, till 1 less than what you have given here. This is the function range for you. It will start from 0 until 1 less than that number. You can also give, so range basically takes 3 inputs. So range takes 3 inputs. Okay, one is the starting number, next is the end number, and this is the increment. Okay, so for example, if you give range of 5 comma 15, and if you give, let's say, 5, what does this mean? This means the output will be, the first number will be 5, then what it will do, it will do 5 plus 5, which is 10, then 10 plus 5, which is 15. But since the end number is 15, it will not proceed further, it will stop right here. Okay, similarly, if I give range of 5 comma 20 comma, let's say, 6, what will I get? It will start from 5, then 5 plus 6, 11, then 11 plus 6, 17, then 17 plus 6, it goes outside 20, so it will not print, it will stop right here. Okay, this is how the range function works. Now if you just give one input, if you give range of, let's say, 10, what does this mean? This means that by default the start number is 0. Okay, the start number by default is 0, and the increment by default is 1. So that means it will start from 0, 1, 2 till 9 it will print. Okay, notice that it is printing 1 less than what you have written here. It is not printing 10. It is printing 1 less than that, because it has started from here. Okay, do you follow, guys? So this is why when I write 3, 8 and 2, first number will be 3, then 3 plus 2, which is 5, then 5 plus 2, which is 7. Okay, and when I write range of 5, it will give starting from 0 till 4, not 5. Okay, so just a small function, range. Now people who know VBA, so VBA is a very popular language. It is used a lot for traditional analysis. So people who know VBA would know what is a break and a continue function. So this is an example of break and continue. So not this is very rarely you will be using this. So what does break do? So break basically, so break will come out of all loops. So let's say if you are inside a while loop and if you write break, it will just exit that entire loop. Okay, continue, what it will do, it will just exit that particular iteration. Okay, so in while loop you go through multiple iterations. Break will exit and directly come out of all the iterations. Continue, what it will do, it will just come out of one particular iteration, not all iterations. It will directly move to the next iteration, that is continue. Break will stop all iterations. That is the difference between break and continue functions in Python. This is exactly same as how it is in VBA. So if you know VBA, they have the same purpose. And this is one example which shows the application. Okay, so you can look through this example. It is very simple. Okay, then we have some other data types which I think I'll cover tomorrow. Since I don't have time, I'll be covering the other data types tomorrow. Okay, so these are not very important, which is why I was trying to skip this, but anyways, since you have asked, let me cover. Okay, so let's say if I write something like, let's say this is my x 1 9 11 20. Okay, so if I write for I in x, okay, if I write if I is equal to 11, then I write break. Okay, now what will happen when I do this? First your I is 1, so I is equal to 1. Is it equal to 11? Or let me write one more thing. Let me write print here, print I. Okay, let me write print I here. So what will happen now? First your I will be equal to 1. So I is not equal to 11. So this break will not work and it will print 1 for me, right? All of you understand this? Then it will print 9 for me. Next will be 11. Okay. Next will be 11. Now when I is equal to 11, it will run this. It will go inside the if condition and break will be executed. Now the moment break is executed, it will just come out of everything. It will just exit everything. So 11 will not be printed and 20 will also not be printed because it has come out. Okay. Now compare this with respect to continue here. Now we don't have break, you have continue. Then what would happen? It will print 1 9 and then it will print 20 also. It will not print 11 but it will print 20. So that is the difference. Do you get it? Because it just came out of that particular iteration. Okay, let me show you the example which I have here. Okay, so let's see this example. This is with respect to while loop. So I have count is equal to 0. Okay, now while true means it will always go inside this. True means it will always be true and it will go inside. So it will print count. No, opposite. Arun, break means the rest of the loop will not be executed. Okay, continue means only that iteration will not be executed, but break means none of the iterations ahead will be executed. Okay, that is the difference. Both means the rest of the loop will not be executed, but one of it means break means none of the iterations will be executed. Continue means only that particular iteration will not be executed, all the others will be. Okay, let's see this example, you will understand. Okay, so while true you are printing count, so that means 0 will be printed. Okay, that is why I have 0 printed here. Okay, next what do I have? I'm increasing the value of count by 1. So now count becomes 2. Sorry, count becomes 1 now. 0 plus 1 1. So count becomes 1. If count is greater than 5, break. So count is not greater because it is only 1 now, so it will not go inside this. So what will I get? Now count is 1, so it will again print 1. Similarly it will go on printing 4. After 4 what will happen? The value of count will become 5. Next what happens? Is count greater than or equal to 5? Yes, it is equal to 5, so it will go inside. It will just come out of everything. Okay, it will just come out of everything. It will not print anything else. Okay, it will just exit. So that is why you have only till 4. After 4 you don't have anything getting printed. Okay, but had I written continue here, it would have repeated. It would have become an infinite loop basically. Okay, it would have become an infinite loop. So that is the difference. Okay, I hope you guys got it. So for example, here you see x is in range 10. That means the value of x will be from 0 till 9. So for all the, so x percent 2 means I'm checking the remainder. Is the remainder equal to 2? Then continue. Okay, that means for all the even numbers it will not print. That is why it is printing only the odd numbers, because I have written continue, so it is not going ahead in that iteration. But had I written break here, it would have not printed anything. If I had written break here, nothing would have been printed, because it will directly come out. Because x, when 1 is divided by 2, you will, sorry, when 0 is divided by 2, you get a remainder of 0. And so if I had written break here, none of the numbers will be printed. It will directly come out. Okay, so that is the difference between the two. Okay, so after this we have comprehension. So I'll cover this tomorrow because this is important. I don't want to hurry through these. So we have 2 or 3 more data types. So one is comprehension, the other is array, which is in NumPy library, and then we have series and we have data frame. So we have series after that, and then we have data frame. This is the most important. Okay, the most important data type which you will be using most of the time. Okay, so tomorrow we will have a 4-hour class. Okay guys, tomorrow we will, or at least 3.5 hours. Okay, today was the first day, so I did not want to take it till 12, but otherwise we will have at least 3.5 hours to 4 hours. We will have 2 breaks in that case. Okay, so this is all I had for today. Let us do a quick revision and then we will close. Yes, Sinu, of course. For loop you can use through any data structure, or any loop, even while loop you can use with any data structure. Okay, but usually used with lists. They are usually used with a list. So quick revision. So what did we see? We saw the first 4 data types, right? So first 4 data structures. One was list. Lists are ordered and mutable, right guys? Then we saw dictionaries. Dictionaries are key value pair. Keys are immutable, right? Values are mutable. And dictionaries as a whole are unordered. Okay. Then we saw sets, which are immutable and unordered also. Then what else did we see? We saw tuples. These are ordered but immutable. Okay. Then we saw what is a histogram. A histogram is used to study the distribution of a quantitative variable. It is used to study distribution of any quantitative variable. Okay. We saw what is a uniform distribution. A uniform distribution looks like this, where you have the variable here and it stays flat. Okay, it stays flat. Then we saw what is a normal distribution. Normal distribution looks like a bell curve. Okay, where you have this as the average and this as the median also. So both median and average, they are at the same point because it is like symmetrical on both sides. Okay, by 50% area. So if this is your histogram, for example, your median means where you get 50% of the area. So if you get 50% area till here, your median will be here. Okay, so median represents the 50th percentile or 50% area in the histogram, in other words. Okay, so this is the normal distribution, this is your uniform distribution. Then we saw what is standard deviation. Standard deviation, it measures the variation in data. Okay, how much variation is in your data, how much is the data changing with respect to average. Always remember this, with respect to mean. We saw the formula also. Standard deviation is the root mean square of deviation from average. Okay, so you start from the right hand side, you calculate the average, then the deviations from average. Since you have more than one point, you will have to sum over all points. Then you take the square of it, you take the mean of it, you take the square root of it. This is the formula for standard deviation. Okay, then what else did we see? Then finally we saw loops. We saw loops in Python. We saw for loop. This is the syntax. So for I in, let's say, a list, then you give the colon and you give indentation. Okay, this is indentation. So wherever you have indentation, it means that is part of loop. Okay, wherever you have indentation. Then we saw while loop. So while I is less than something, let's say 5, you give colon and then you give indentation. Okay, and remember, when using while loop, you must provide an increment. Okay, so at some point this condition must become false. Okay, at some point, if this is always true, you will end in an infinite loop. Okay, and what else? We saw if else conditions. So you can use if condition 1, then indentation. Similarly, elif, you can write condition 2, then again indentation. You can add as many elif as you want. Elif condition 3, you can give indentation and so on. And at last you just use a else. Okay, indentation, so that if none of the conditions are true, at least something will be executed. That will come under else condition. This is if elif condition. Okay, we saw break and continue. So break means comes out of all iteration. Okay, continue means comes out of the current iteration only. Okay, yeah. Anything else? Did we see anything else? We saw the range function, right? We saw the range function. It takes 3 inputs: number, one is the end number, and the increment. Starting number by default is 0 and increment by default is 1, but this is mandatory. This does not have any default value. You have to give this number. Okay, So you can get help in a Jupyter notebook. If you want to get help, for example, you can press Shift Tab. Okay, let me show you. So let's say you don't know how range function works. Just write range and press Shift Tab. If you press Shift Tab, you will get this help page. Okay, so you see, and if you press this plus here, you will see some examples also. Okay, 1 second. So Shift Tab, and then you see some examples will be given here. It will tell you what is the syntax and all. Some explanation you will get. Of course, you can always Google and go to Stack Overflow. But within Jupyter also you have, so you see range start number, then your end number, and then the step. Step means that increment. Bala is asking how do we install Jupyter. Bala, I already shared that detail. I shared it in the previous video in the day 0 class. I have shared that video on the group. I will mail it to you anyways today. Yes, it can be decrement also. Bharti, that is true. You can give minus sign also. Okay, so guys, get Jupyter installed on your local personal system, and I would also suggest you to get it installed in your office system so that whenever you get time you can practice. The more you practice, the better you get at it. Okay, so guys, do you want the assignment today or do you want me to send it on Monday? Assignments, because I did not complete all of it, so some of the questions in the assignment might be outside of what I have covered. It will be what I'll be covering tomorrow. Anyways, I'll share it today, no problem. So maybe give me a couple of hours. I will just arrange the assignments and then I'll send it to you. Okay, I don't have your email IDs also, so I will share a form right now. Please write down your email IDs in that form. Okay, so that I'll have everybody's email ID.